Piecewise, domain, and range. So on the top, we have a review of the different notations that you can use. We have interval notation, which involves a small number, the biggest number. If there are brackets, that means that we would have had an included value, so a solid. If it's parentheses, that value would not be included, so that would be an open point and even infinities. For set builder, you have the set of whatever variable you want, and then as long as, and then an inequality that must be true for it to work inside of that domain or range. The difference with piecewise is you're going to have graphs that are broken up into different sections or pieces. So if we need to join two sections of domain and range, if we are in interval notation, we are going to use the union symbol, which is looks kind of like a U. In set builder, we're going to use a word, and we're going to use the word or. So here's a quick number line example. Notice that there are two sections of shaded areas. And so when you do your domain or range, you're going to work with it like two separate equations in one. So for the first shaded area, the lowest number that you have is -4, and the highest number that you have would be -2. -4 is open, -2 is closed. And then you have a gap. And then for the second section, the low number you have is 1, the high number you have is 3. And so this gap in here is what we're going to use that U or that word or. So for interval notation, we start from the left. So we have -4 is the low number, comma, -2 is the high number. -4 is going to be parenthesis because of the open circle. -2 is a bracket because of the closed circle. And then inside that gap, this is where we're going to use that union symbol to join the two sets of domains. And then the other one, start just like we did with the blue. 1 is your low, 3 is your high, 1 has a close, so we need a bracket, 3 is open, so we need a parenthesis. Using this, you successfully joined the two sections of your domain. Now let's do the same thing in set builder. So we're going to have the set of x's as long as, and then we're going to write two inequalities. So our first inequality comes from the first section. -4, open circle means less than, x in the middle. Our high value is closed, so less than or equal to, and then -2. And then for set builder, instead of using that union symbol, we use the word that it represents, which is the word or. And then the second section starts out with a 1, and because it's closed, it's less than or equal to, x in the middle, and then the open circle would be less than 3, and that would be the end of our domain overall. Okay, so let's try a two-dimensional example. We are going to do domain and then range. So domain works with your x's. So that's going to be left to right. So we're going to take the guide that we have, and we're going to start on the left, and we're going to drag across to the right. As long as your guide is touching part of your function, you do not have to stop. And we're going to write on our x-axis. And so the first thing I notice when I start this is we hit an arrow. So that arrow is going to tell us two directions. That arrow tells us up and left. And because we're doing domain, we know that the left is what we care about. So it's going to go left forever towards -infinity. Then we take this and we drag, 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 and notice that this is the first place I have to stop. Because after this point, there's nothing to connect this point to this point, left and right. I hit some open space here in between. So the first place that you're going to have to stop is at -2, and I'm going to put an open circle there, and we're going to connect those two dots together. So there's like a section of our domain. And then let's continue. So now we take our guide and we go to the next starting point, which is here. From here to here, there's nothing in between, so I can't include that. But now that I've started from this point, I can now start back at 0. So I had to do a little bit of a jump. And then we're going to drag this across until I hit my arrow, which means that we are going two directions, right and down forever. And because this is domain, we care about the right. So we're moving right forever and ever and ever, connect those two together. And we have a number line that represents our domain. Notice how this is exactly what we did back up here at the top with our little number line. And there is in fact a gap right here in the middle. So when we do our domain and range, we're going to have that union or the word or. So let's start with interval. So the lowest overall that we're going to go is -infinity. So we're going to put a parenthesis, -infinity, comma, And then the first place that I have to stop is this -2 because that's where the gap begins. So we're going to go all the way to -2 with a parenthesis because of the open point. Now the gap here is going to be represented by that union symbol, that U. And then the next set picks up. So now we start here at 0 with a bracket after the gap, and it goes to the right forever towards infinity. So the two sections of our domain. If we translate that into set builder, it's going to be the set of x's such that. Now, because there's an infinity on this first one, we need to take a closer look. So the boundary number that we have is -2, and our shade is everything to the left, which means these numbers are all smaller than -2. So we write that as x is less than -2. Because there's a gap, there's that union symbol, we're going to have to use the word or for set builder. And then we start the other side, and we notice that there's another infinity. So let's take a closer look. Your boundary number is 0, and it goes to the right forever, so all of these numbers are larger than 0. So we have x is greater than or equal to 0. Equal to because the point is closed. Let's do the same idea, but for range, bottom to top. So we start our guide at the bottom, and we work our way up. The first place that we hit is an arrow. So we know that our range will be down forever towards -infinity. And then we're going to move our guide up. So we start at the arrow, up, 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 and stop here. Notice again how this point and this point have no y values in between them to connect them. So I have to stop there first. So let's move this out of the way just a little bit. We have to stop here at -3, and we're going to connect those two ranges together. There's our first section. So now take your guide, start it back at the next section, which starts here at that open point, which has a y value of 0. I'm going to put a big open point around my domain. And then we move up, 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 and I notice that I hit an arrow, so that means we are going to move up forever on my range for that section. And that takes care of all the sections of the graph. So if we look at our overall range, we do in fact see that there is a gap between my two shades. So I'm going to have another union or OR. So let's start an interval. So the lowest that we go is that -infinity for the first section, comma, and then the highest, the stopping point that I have to go to is this -3. And it's going to have a bracket because it's a solid point. Then to represent this gap here in the center, we're going to have the union symbol. And then we start at the second section. Start here. The starting point would be 0 on the y. Again, we have a parenthesis because of the open, and then it goes forever up, which we call infinity, which will have a parenthesis. So for set builder, we're going to translate this again. So we have the set of y such that, and again, I see an infinity, so let's think about what's really going on. -3 is the high point, and all of these numbers are smaller than -3. So y is less than or equal to -3. That union, that gap in the middle is going to be the word or. And then we do the other side, which also has an infinity. So the low number is 0. All of these are larger than 0. So we say y is greater than 0. You may not always have a gap, but if you do, you have to use the union for interval or the word or for set builder. Now let's try the evaluating. Okay, so for evaluate f of -3. So remember that if this number is on the inside, they are giving us the x value, and we are looking for the y that goes with it. So on the x-axis, you're going to find -3, and you're going to either move up or down until you hit your function, the curve, the line, whatever graph is on the coordinate grid, which would get me here. And that y value is about 0.5. And because it's solid, we are allowed to actually have that number. So f of -3 is equal to 0.5. F of -2 is similar. Again, that -2 is inside your function. So that means that x is -2. You are looking for the y value. So on the x-axis, find -2, and we are actually already on the function value right here. There's no need to go up or down, but I do see that it's an open point. So if it's an open point, that means that we are not allowed to actually hold the value of -2. So what we say is the function value at -2 is undefined. Let's take a look at the next example. So we have 3 sections this time. So let's try to do the domain and range of each section. So we start on the left if we're doing domain. So we're going to move our guide to the left, and I see that it hits an arrow right out the gate. So that arrow means that we're moving to the left forever, so -infinity. And then we're going to move our guide. As long as our guide is touching the function, we do not have to stop. So we go, 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 and I notice that if I stop right here, I do hit both sections of my graph. Now it's important to be careful and notice the type of points that you have. So right here, the point is open, but here, the point is closed. So what that means is that means that you actually are allowed to have -4 because this one will actually fill in that top point. So I can actually keep going. Go, 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 go to the right, to the right, to the right, and then I hit the same kind of situation here. I hit this part and this part at the same time. This is closed, this is open, which means this fills in that gap, and so there isn't a gap. I'm allowed to keep moving. Go, 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 and we stop at an arrow, which we know really means that we're going to keep moving forever in the right direction. So really, yes, there are 3 sections of the graph, but because all of the different sections of the graph were covered up by something else, we do not actually have to stop. So we do in fact go left and right forever. So our domain would be -infinity to infinity. And in set builder, that's our all real numbers. So it's the set of x's such that x is an element of the all real number set. Let's try range. Maybe there's a gap in range. So again, take your guide, work bottom to top. Now, when I work bottom to top, I notice that these two are at the same height. I hit this arrow and this point at the same time. But this arrow means that we're going to move down forever, so this is not actually the lowest point. This arrow says that we're going to move down forever, so -infinity is actually our lowest point. And then we move our guide up. As long as our guide is touching the part of the function, we are okay. So I already know that this is touching part of it, and so we're going to move it up. We're going to move up. I hit this arrow, which actually also means down forever, which we have already included right here. Let's keep moving. We go up, 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 and I'm going to stop right here for a minute because I do see that there's a dot right there. This dot is open, but because this is a solid line and this is a solid line on that same y value, just like our domain, this guy was closed from here and here. So there's no gap yet. I'm still good to keep moving. Move, 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 and I'm going to stop here. Again, if we notice, open point, closed line, these will actually fill in the gap of the other one, so we're good to go there. Up, 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 and we stop. And if I stop here, we notice that there's nothing else up here. This is a point, so we're not going to keep going. So our highest value is 7. And similar to domain, because all of our open points were closed in with the solid lines, there's no gap here either. So just because there's sections doesn't necessarily mean there's going to be a gap. So for my range, the lowest overall is -infinity. There was no gap anywhere in here because these two y values took each other's place, so that was fine. So the highest it went was 7 with a bracket. So not quite all real numbers, but close. Let's translate that into set builder. So we have the set of y's now such that, and I see there's an infinity, so let's take a closer look. 7 is the high point. All of these are smaller than 7, so that means y will be less than or equal to 7. Pause the video, try these two evaluates. Let's check. So the inside was -4, which means the x was -4. You were supposed to find the y. So if I look at x is -4, I see that I'm already sitting on -4, but it's an open point. So I'm not allowed to have that value. But if I look down, I see that there's a closed point that also has an x value of -4. And we are allowed to hold values of closed points. So this is going to be the function value at -4, which gives us -3. The next one is similar. This is your x, go find the y, take 1, and if I look up, I see an open point and a closed point. So we're not allowed to carry the open points, but I can have this value, so my answer would be the y value of 7. The function value at 1 is allowed to equal 7, not 2, because of this open point. Pause the video, try to write the interval notation for domain and range. You can try set builder as well, but definitely try to get interval. Let's see how we can do. Okay, so hopefully we had this shaded region for domain, and we noticed that it went from -infinity and had to stop at 2, because if you use your guide, that 2 does not actually touch this other part of your function. These two are not connected on the same x value, so you do in fact have a gap. You start back up at 3 and it hits the arrow and moves on forever. So because we have this gap, it moves from -infinity to 2. The gap is the union. And then we have the second section that starts at 3 and moves on to infinity. Range is very similar. Start at the bottom. We have -infinity and we move up. We should not have stopped at -2 because yes, even though this is an open circle, this closed circle actually fills in the gap. So we don't need to stop. And then we go up to 2. However, this y value and this y value are two completely different ones. These two are not connected on my guide. And then we have to pick back up, start at the second section at 4, and move on to infinity forever. So our first section was -infinity to 2. The gap is my union. And then the second section was 4 to infinity. Pause the video, try to translate those into set builder. Okay, check your work. F of 1, find the y value when your x value is a 1. X is 1 because it's on the inside. So if I look at my function here, I'm going to follow the x's to 1, and I see that it actually hits the function at also a y value of 1. So f of 1 is equal to 1. Now the next one is slightly different. F of x equals 3, this is our y value. So y is equal to 3, it doesn't know what x gave you that. So on your function, you're going to look for a y value of 3, which is here as a dashed line, and see where it hits your function. But if we notice, this doesn't hit either section. So that means there is no x value to give you a y value of 3. So in this case, x would be undefined. There is no x's that will produce a y value of 3. Try the next example on your own. Go ahead and pause the video and try all the pieces of this next example. Okay, here are your solutions to example 4. We're going to skip example 5 and try out example 6 together. Okay, so for domain, again, we're going to work left to right. So we're going to take the leftmost point, which on the left starts us out here at -1 with a solid point. So we're going to drag that down to the x-axis, and then we're going to work our way across. As long as our guide is touching the function, we don't have to stop. But I notice at this point that I do have an open circle and there's no other solid point, solid line to fill in that space. So this is actually a gap in my domain. So I'm going to have to drag that up as an open point and just connect those first two. And then if I notice afterwards, I have all of this shaded line right here, so I can keep moving. I'm going to go ahead and go, and then I notice again that I have another open point. This open point doesn't have any solid anything along my guide. So again, I have to drop an open point to my x-axis. So we're going to drop an open point, shade in the middle. And then we continue on from here, because I have all that solid line, solid, 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 and stop here at a solid point. I have 4, and that's the furthest to the right that this graph actually goes. So if I look at what I do in fact have little tiny gaps. This little open point right here is actually a small gap, and so is this one. There's nothing too shaded in. So those are two very small single number gaps. And so when we write our domain, we're going to have a union or an OR. So the furthest left is going to be a bracket at -1, and then the first gap that I have is at a x value of 0. It's open, so I put a parenthesis. And then because there's a gap, I have to put that union, that OR. Now here's the weird part. You pick back up right at 0, and then you go all the way to 1 with another parenthesis. Gap, pick back up at 1, and then go to 4 with a bracket. So what happens is, what this means is with this union and these two parentheses, that means you have to skip the value of 0. I can have all of these negatives, but I have to like jump over 0, all these positives, jump over 1, and then all of these numbers to 4. So this is what a gap of a single number looks like in interval notation. If we translate that to range, it's going to be quite a few inequalities. So we have the set of x's such that -1 less than or equal to x less than 0, that word or for the gap, and then we have 0 less than x less than 1, or for the gap, and I'm going to write it underneath because I'm running out of room, and then we have 1 less than x less than or equal to 4. So this is clearly a lot more writing than interval, especially when you've got single number gaps or multiple gaps. Let's work with range, bottom to top. So again, start your guide at the bottom, hit -4. That's the first dot that we hit. So we're going to mark that on our y-axis here. And then I'm going to move my guide up and make sure I don't have any gaps. So we go up, 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 and I'm going to stop at this point and just check. I notice that this open dot has this solid line to take its place. So there's no gap here. This has a spot to fill in. And we're going to move up, 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 and then I see a solid, 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 so there's no need to worry about any three of those. Up, 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 and I stop at an open point here at 5. So range actually didn't have any gaps at all. Range was solid from -4 to 5 somewhere on our graph. So there was no range there. So we write that as -4 with a bracket to 5 with a parenthesis. No gaps needed in the range. So we have the set of y's such that -4 is less than or equal to y, which is less than 5. So just because there's a gap in domain doesn't mean there'll be one in range. Sometimes there is, sometimes there isn't. Pause the video, try these to evaluate problems. -1 is the x, find me the y. So if I go to -1 on the x, here's where it hits my graph, and that has a y value of 1. And there's no other options on an x value of -1. And now my y value is -1, find me the x. So my y value of -1 is right here on that purple dashed line. I see that it does hit at this open point and at this line right here. But remember, we're not allowed to have open points, so this is the only option. So my x value that gives a y value of -1 is 3.